Good afternoon. For all the participants who is joining this course, my name is Tien-Yin Chou. I'm from Fengshan University. So this afternoon, I'll have 2 hours to explain to you what the course is and what's the purpose we're doing this course for you. And also, basically, there will be 16 different kind of courses offered every Monday afternoon, 4 to 6 o'clock in Taiwan time. So my name is Tien-Yin Chou. Everyone call me Jimmy. I'm the Director General of the GIS Research Center in Fengshan University in Taiwan. I'm also the Dean of the College of Construction and Development in Fengshan University. Let me express my welcome to all of you who joined this course now. So the basic outline for my course today is for the first session, I'll spend several minutes trying to introduce to you the introduction to this SOS development course program. Why we have this program designed to offer to either international or even domestic students, especially regarding to the Asian students or Asian who is interested in the remote sensing issues. And the session 2 is my topic about what is spatial information, especially about the GIS, about the GNSS, about the remote sensing, and also those kind of data types and some kind of map elements, and especially about the projection and coordinate systems. And session 3 is about the structure, like the basic GIS data, concerned about the vector data, raster data, or even some kind of service data, like the DTN, DEM, DSM. And also session 4 is about the remote sensing, like the introduction to remote sensing, aerophoto, satellite image, aerophoto by the UAV. Okay, so I think all of you can see my PowerPoint now. Let me introduce again about myself. My name is Tien-Yin Chou. I'm Jimmy. So I'm going to talk about the Geospatial Information Technology Introduction to the 3S. So this is an outline of today's course. So there will be session 1, session 2, session 3, and session 4 is about the remote sensing. And when I say remote sensing, some of the basic idea about remote sensing and also the basic information came from aerophoto, satellite image, or even a UAV or some other sensors. And also the most important one, the GNSS. Before, we use the word, say, GPS, but now it's not only the GPS can offer the kind of GNSS service. So there are GLONASS, there are Beidou, there are some other very, very good satellite can also offer some kind of global navigation satellite system. So we call that as a GNSS. And also the last one is replication of some of the spatial information. But today, my basic information about the spatial information application will be roughly a very general talk about several things, about the disaster prevention, about transportation, about the 3D city planning. And in further courses in the future, for the next several courses, I'm going to share with you some even further discussion. So let me go to the first one, the session 1, the Introduction to SOS Development Course Program. This program was launched by Taiwan Space Union. We consider about if all the countries or those people who is interested, especially for some of the students who has very strong interest in the space observation and sustainable development issues, then Taiwan, several universities work together, try to offer this course online, and basically is free and it's open access to everyone. So this course will start from February 14, from today. So today is February 14. This is also a day we say Valentine's Day. So let me express my happy Valentine's to all of you who is listening to this course now. And this is from February 14 until June 13. So there will be 16 courses offered every Monday afternoon from 4 to 6 o'clock in Taiwan time. So make sure you're joining us every Monday afternoon. This course about the space observation and sustainable development course is trying to combine some efforts from National Cheng-Kung University, National Central University, National Taipei University, and also Fengjia University in Taiwan. So we try to have all those scholars. They all have very, very good expertise and experience in the remote sensing, either theory or application one. So the students, you'll be able to interactive during the lessons. So I would encourage, if any of you have any question or anything, you're not understand too much, or you have any question, you can just easily open your microphone and speak out loud. And I think all the teachers or instructor will be happy to answer your question. And for each course, so after the 2 hours introduction in the courses, we'll have a very, very simple quiz for all of you who was listening to the course, or even in the future, since all the courses will be recorded. So anyone who is interested in the course, if you listen to the course or review the course, then you'll be able to very easily answer some of the quiz questions. And use the quiz questions, there will be a Google Doc document. So that document will be shared by the manager of this course, and he will show you how to provide the correct answer or some kind of short essay questions to Google Doc document, and that prove you've been listening to one of the course in that one. So hopefully we can have all the students who join us together. So there will be several things. First, introduction to this kind of 3S technologies, and then the mobile mapping technology, which is very important nowadays, and also disaster management, since the climate change and all the nature disaster. Basically, we're going to talk about the nature disaster. So how each country managed the disaster management, and also what kind of technology we used regarding this kind of very serious disaster, and also some analysis and some case study. So these are the course website. Of course, if you join us now, you're no problem to join with the website. And all those 16 courses will be divided into different sections. So there will be 4 major things. And for the last one, to the June 13th, it will be a final exam. Of course, final exam will not be a very, very serious face-to-face closed book exam. So it will be a very, very open, and we hope all those students or all those who are interested in this course can also join us in June 13th. And also the lecture is from all those 4 universities. I'm the first one, the Professor Tien-Yin Chou. So I'm going to talk to you today for these 2 hours courses. And also there will be other professors from all different universities talk to you in different courses. So as you can see from the PowerPoint, some of the course will be very, very interesting to you. And also some course is talk about some theory, but basically we try to focus on some of the application things, because we know for all the students who join this course, you might came from different kind of background. So we love to share all this kind of information with all different kind of, especially we say interdiscipline students, interdiscipline scholars, interdiscipline experts from all different fields. So let me go into the session 2 for my talk today. So I'll try to talk to you, what is the spatial information? Why we say the spatial information? And also some of the introduction to the GIS. The geographic information system is very, very basic thing. Is many years ago, some of the scientists, very, very smart, and they try to develop a kind of things, try to show up what is the real world. For example, the real world we're looking at is everything is on the 3-dimensional. And also we can identify, for example, in front of me, there's a notebook in front of me, and there's a PowerPoint designed course material. But if the computer can recognize those kind of issues, if the computer can recognize this is a notebook, this is some of the PowerPoint about the course content, and there are several scholars in the world, especially from the US and also from Canada, they try to develop the first GIS because of the land information needed, and also from Australia. So some kind of GIS has been started from US, from Canada, from Australia. And they've been started using the computer. And computer use the binary code, like the 0 and 1. So how we can just use 0 and 1 to represent the real world. So that's a GIS. So if we can make a real world to be expressed and to be analyzed in the 0 and 1 format, then we say it's digital information, and also we can analysis. So some of the establishment of the foundation of the geographic database, for example, 30 years ago, when the GIS was first launched, that time the graph and the table are different things. But now we can put all the information, the useful, we say, attribute data into the graph. So we can combine with the map and also its attribute data together as a feature. So this feature enable to extract, to edit, to update, and to save the data in query, process, analysis, and display. So today I'm going to show you some of the example, how we can extract, how we can edit, how we can update and saving or in query, process, analysis, and also to display. For example, this one is one of the graphic data, one of the water reservoir in Taiwan. So the red, this one, the red line represent the area of the water reservoir. And also these black one means the administrative boundary for different county, different city. And also the blue one means the water body itself, and also those kind of stream or creek. And also the green one is a contour line. So in this graph, there are lots of information. The contour line, the water reservoir entire area, the water body, the stream, the creek, and administrative boundary. So there are lots of information. And among all those information, if we say this is a polygon, the computer itself will know how large, what's the area size of this watershed reservoir, what's the size of the water body, what's the length of all the stream, all the creeks, and what is the area size of this political administrative boundary. So all this kind of information, we say it's attribute data. Before, like more than 35, 40 years ago, we can still draw this kind of map. We can still use the table to represent this kind of information. But two things are separate. But now, what is GIS? GIS means those things are joined together. So if I put my arrow into here, I know exactly what it means. If I see the area, I know exactly what it means. So that means the GIS has combined together with the graphic information and attribute information. So we say, what is the GIS? It is the graphic information together with the attribute information. So some of the formation of the GIS started from 30 years ago. You have to have some kind of hardware. Like before, it was a PC computer, then the kind of workstation. But now it's notebook, it's cell phone, it's computer, it's server, or everything is on the cloud. And also you need software. And before, there was very good commercial software in the world regarding the GIS, regarding the remote sensing software. And now there are open access or open source software can be maintained by volunteer. So there are lots of different things has been happening in the world. And also the kind of data about the shapes, about the graphics, and also the attribute data. So that's the most important. And also regarding the GIS, we always say if someone is interested in the GIS, it's one of the good things. If you're drawing a map, if you analyze something, you have to have different background. You need to have some background about the GIS. You need to background about some of your domain knowledge. For example, if you're an expert in the disaster management, then you must have some kind of background about those kind of disaster issue. If you're an expert in the civil engineering, then you have good background in the civil engineering. If you are an expert in agriculture, then you have the good background in the agriculture. But everyone can use the GIS as a tool to represent all the graph and attribute data and do very good analysis. So that's the good things of the GIS. So GIS require a teamwork because no one is the domain knowledge about all the fields. So, and also you have to have some very good methodology or algorithm. So because using this kind of different methodology or algorithm, then you'll be able to analyze, or you can have some kind of model to predict something. So I'll try to explain this in more detail in further explanation. So while we're looking at the real world is like this. That's the real world. But for computer, for 0 and 1 binary code, we have to identify all these kind of different things as different layer. Like one of layer is construction, one of layer is the river, one of the layer is transportation, one of the layer is land use, one layer is some other information, the public facility like the pipeline or the sewage system. So if we have all these kind of different layers, then we join together. Either it's a vector, use the point, use a line, use a polygon, or the raster. Raster means each pixel or each cell has different information. Either it's one of the color represent different spectrum, or even one of the number represent the intensity or whatever, just like you're looking at a photo. So each pixel or each cell has different meaning. So that's mean the raster information, like the satellite image, like the photo, that's all the raster information. So we can join together with the vector information, raster information into different layers. And all those kind of layer, we can analyze the entire real world. So the entire real world is a complex information. So this is the good thing of the GIS, because we try to start the GIS from the two-dimensional things, use the 0 and 1, use the vector data or raster data. But now we try to use the three-dimensional one, or even the four-dimensional, represent the time, the series. Or we can use the AR or the VR. If you look at the new movie, there are lots about the movies, talk about how people can use the AR or use the VR into different world. So there are so many different kind of movie represent how you can use the 0 and 1 to represent your real world. Like the most update Matrix, the movie Matrix. So it means you cannot identify what's real, what's not real. And the matrix is something still they try to use the 0 and 1 to represent the entire world. So this is one of the benefit of the GIS. And concern about the remote sensing, these are some of the slides I borrowed from the Digital Globe company. The Digital Globe company they have very, very good satellite, commercialized satellite, and they produce very, very good satellite images, serve the entire world. So the commercial remote sensing industry pushing the limits of the spatial, spectral, and temporal resolution from the space. For example, they can offer even up to 20 centimeter of the resolution now. You can just buy it, use your credit card. And the spectral resolution, like before, most of the satellite, even for the SPA satellite from France, or the Landsat satellite from US, Landsat satellite has 7 bands, including the thermal one. SPA has 4 bands, but now the most updated remote sensing satellite, some satellite, they contain 16 bands. They have lots of near infrared, thermal, and lots of information, which enable so many different kinds of analysis will be able to operate. It's much, much better than before. And also the temporal resolution, like before, we have to wait for weeks or even for months to have a satellite passing through certain area. But now, just few days or multiple times a day, it's possible to have the satellite passing by your area or some of the interest spot. And also the radiometric resolution is also very, very detailed. Like before it's 11 bits, now 14 bits. And angular resolution, and you can vary off the nadir, which means all the satellite will be able to not only for the author one, but it can adjust the angle of the satellite, which means it can has the much larger size or the detect area than before. So like the spatial resolution, nowadays, for example, this is commercialized satellite image offered by the Digital Globe company. It's less than 19 meters, 9.5, 4.7, 2.4, 1.2, and 60 centimeter. So it can, or even 30 centimeter. So it can all represent, as you can see from the screen. If you're looking at the 20 meter, for example, like the Landsat 1 from 1972, the resolution is nearly 70 meters. And the spot from 1986, resolution was 20 meters before. But now, most of satellite, they can offer 10 meter, 5 meter, even 2.5 meter, 1.2 meter, or 60 centimeter, or even 30 centimeter. And now there are some most updated satellite. They can offer even up to 10 centimeter. And before, it's nearly impossible for several hundred kilometers away, and you can have very, very good resolution looking at several centimeters detailed information. But now it's all possible. It's all possible. And also the spectral resolution, for example, like this is nature color. This is the green and white. And this is some of the different, like the near infrared or some other things. We can look at the same places. Even look at, for example, look at the ocean side, look at the land. So we can use different bands to identify even different vegetation, even different submerged vegetation under the ocean. So we can use different kind of bands to identify. It's nearly impossible before. So like before, there's only nature color or just near infrared, but now there's so many bands, and we can use lots of information, even for the spectral resolution, for near infrared, and this is not visible by human eyes, or SWIR. So this is also not possible by human eyes, and also up to even some for example, this joined together with several different spectral together, and also there are lots of very good accuracy, because nowadays the navigation satellite, and even for this kind of remote sensing, a spectrum satellite, they can offer very good, we say, coordination systems. So this kind of accuracy is much accurate than before. So there's lots of technology has been increasing, and also the information accuracy with the data consistency. For example, this kind of information, we can use some other information to represent all the same area. We can use some good technology, try to use, for example, this is a kind of a fade because of the climate or the fog or the cloud. But it is possible we'll be able to eliminate some of the effect by the fog, by the cloud nowadays, and we can enhance. So all this kind of good information, we can join together, like the specialty database, like the building, and with its attribute information, and for example, the roof material, and also the digital service model, like the elevation, about the height, and high resolution for the land cover map from the satellite, and building footprint extraction, high resolution satellite imagery, all this kind of information with vector data from point, from line, from polygon, or raster data by different analysis model, or directly from satellite information, then we'll be able to use that. So if we say remote sensing, there has already been millions of satellite images taken and downloaded to ground station per day. And there are so many different satellites, and also by aerophoto or by drones. Even for the drones development today has been increasing a lot about the technology, about the possible things. Even for the SpaceX company, they try to produce the Starlinks. The Starlink try to have the communication and also the navigation, and spread out entire globe. So they have thousands of the satellite is operating today, and they're looking at more than 10,000 satellites can operate for the entire world. So those can be all serve as good database. So we're looking at different data sources from satellite, from aircraft, from drones, or from sensors. So there's so many kind of information can provide this kind of information today. So we're not like knowing nothing from the office. We can know everything from the office, thanks for the development of the technology, for the satellite, for aircrafts, for the drone, for the sensors. We can know everything, but still, we still need a very good operate system to develop. For example, we're looking at multi-scale, multi-dimensional things. We're looking at different places. We try to use the satellite image like this one. We try to use the air photo joined together with a digital elevation model to represent the really three-dimensional things. We try to use the drone to have this kind of video or a photo to represent a very detailed information. All this kind of information is accessible, is possible to be collected nowadays. And some information is very easy or very simple to be collected directly from the cloud. So there are lots of very good information. So that's why I was talking about the spatial information. So let me explain to you what is the spatial information, especially regarding the data types and map elements. So as I mentioned about spatial data, attribute data, what I mean by the spatial data? The spatial data means we can either use vector or use raster information to represent by point, by node, by line, by arc, by polyline, by polygon, by area, by region, by surface, or even nowadays we're looking at the three-dimensional things. And all the attribute data, like the text and numbers, can be recorded for the GIS element in either we say nominal data, which means the name, the title, the real number of each spatial data, either point or line or polygon, or ordinal data, which means it has different sequence, or it's the size of the polygon represent the impact factor or the interval ratio scale. So that's the different kind of attribute data can be represented. So all this kind of information will be able to be presented in a GIS database. So GIS concerned about the spatial data, about attribute data, and it can be organized by nowadays all the information. But regarding for the map, we have to know how we create the map. Since in the real world, the world is a three-dimensional real world. But if we're looking at a map, it's only a two-dimensional things. Or even we use the AR, VR, then you can go to the three-dimensional, or we can even just like touch it. But still, we have to know how we can make two-dimensional or three-dimensional issue into 0 and 1 digital format. So there are several things. One is the projection, because any places, any area in the globe, in the area, is not a flat one, because the Earth is not a flat one. So we have to have some kind of projection, and we have to identify different kind of coordinates. In the world, there are international coordination system. In each country, it has its own coordinate system. Like in Taiwan. In Taiwan, we use transfer Mercator 2 degree as our basic coordinate information to describe any part in Taiwan. And also the scale. If we're looking at 1 to 50,000 map, or we're looking at 1 to 100 scale, it's completely different, because the larger scale means very detailed. The smaller scale means a very roughly, but has a larger size. So we're looking at the projection. And for example, this is one of the original Taichung city where the Fengjia University is located at. So this is the urban area of the Taichung city. And we're looking at a map, we're looking at different things, because we have the scale, so we know exactly the size of this map. We know the length of each represent, like this is one of the express lane, and this is one of the industrial area. And also we have the north, east, west, and south, the direction, the orientation of the map. And we have different polygons to represent some of the park, some of the industrial area, and the school. For example, this is the Fengjia University, the case at the central of the Taichung urban area. And also with attribute data. Attribute data means it tells the entire map use the transfer Mercator 2 degree. And so what's the easting, the northing, and also about the latitude, the longitude. All this kind of information will be able to see directly from the map. Then this map we say is a map with a graphic and also with its attribute data. So there are lots of information can be described in just a very, very simple or easy maps. And also all this kind of map, it can contain different kind of number being provided from relevant information. So there are lots of different information can represent the entire area. So that's how we say the GIS, we say the spatial information, we say everything is joined together with the graphic information, with the attribute information. So when we use this kind of things, then we can produce the electronic maps, because all the things is represented by either 0 or 1, and also it can be displayed. So this is a very, very simple way to display the entire area. This is also one of the major watershed reservoir in Taipei area. And also, if we're looking at the different commercialized things, we can be very, very easy to use just the Google Earth service and to join together with some other information we already produced. So it's very easy, but because all the maps use the same kind of coordination and use the same kind of projection, then we'll be able to overlay all the information together. For example, this is the entire Taichung city area. And if we're looking at some of the very detailed one, and these are some of the satellite image or the aerial photo. And we have all the information about each slopeland, each slopeland parcel. If someone, the landowner, need to do some kind of slopeland development, he or she has to apply it to the government. The government has to approve that. So we can use this kind of very, very simple system to check if this slopeland is inside of certain restricted area. For example, if the slopeland is in some kind of conserve area, or some kind of watershed reservoir area, or what kind of vegetation is growing under this land. So all this kind of information, we can very easily join together, use the Google Earth, use lots of different kind of information, and has the raster data, including the vector data, and join together, use different kind of layers, and we can see the real world. We can see what was before, and we can see what is now. And also with all the attribute data, and we can put lots of different kind of issues, marks into this kind of maps. So this will be very easy to make once you understand what is the GIS. So regarding all the projection and the coordinate system, because we're looking at the Earth, and the Earth is not a very, very perfect round circle, and is not the perfect geometric things. So how we can identify, for example, the Fengjian University is located at the latitude and the longitude, but how we can represent, use the latitude and longitude. The latitude and longitude is the direction, about the orientation, but it's not about the area, the size, the length, because it's different. So we still need to have some way to calculate the geodetic data. So this is, for example, if you have the background of the civil engineering, of the background of the surveying, you must already learn lots of this kind of geodetic data and things. But for each country, it's all different. So we need to have lots of different kind of geodetic coordinate system to be included together. For example, the GeoID and the service, and also the sea level as the GeoID for each part or each land parcel. So some of the area might be the best places for the geo ID. Because if we're looking at the entire Earth, that's the polar and also the meridian and the equator. So that's how we use and how we explain the east and the north, or the west or the south of each particular sites. And also in the world, everyone agree from the Greenwich is the measuring is 0. Then if we go to the east side, then is 118, and another 118 it go back. So this represent the 0 of the meridian is the Greenwich in England. So that's the 0 places. And because the Earth is not a flat land, so if we try to make it as a map, we have to have certain kind of projection, and we have to agree on that. So historically, there are lots of very, very brilliant people. They look at the sky, they develop some kind of mathematics and physics, and they looking at this, and they produce the map projection. So there are lots of different kind of map projection has been developed by different physics or mathematics, like this kind of map. So as you can see, the longitude and the latitude is not on a straight line. Only the latitude is a straight line, but the longitude is not, because it's a conic projection. So there's different type of the projection. The conic projection, like these three, the conic projection is under the positive or oblique or horizontal axis. The horizontal axis is also, we can say, it's a kind of transverse. And also with the cylinder one, the cylindric projection, and we're looking at the positive one or the oblique one or even the horizon, so we say the transverse. So in Taiwan, we use the transverse Mercator 2 degree. So each 2 degree, then it separate the meridian, one of the meridian and 1 degree, 1 degree. Then that's the area we identify Taiwan is about here. Then we identify the entire Taiwan, because Taiwan is under, from the west to the east is about 2 degrees. So we use the transverse Mercator 2 degree as our kind of data. And also there another way to represent either the north or the south. And still there's a positive, there's the oblique and horizontal axis. So, but it still depends on where is the light source. If the light source is from one of side, or light source is a GeoID in the central, then that's different. So that's different. So how we can make the projection is how we can create the map. Because your projection is from far, far away, then the maps looks like this, because it's nearly very far, far away. So everything is go very, very straightly. So it's different. And if the light is in the center of the Earth, then it's different. All the projection is completely different. It either the light's from here or the light's from there. So in the world, we have to have one common used one. So in the world, there are several different kind of projection. And each country has developed its own projection following by international standard. So we can use the coordinate projection, and there's also the good side of that, or we cannot say the bad side, but it's a disadvantage of this kind of map because the distortion is too large. Yeah, so this is the like the corn, and also and this is also like the corn, just like the ice cream on the corn. So we use the corn, the conical projection, but it looks like this way. So it's completely different. If we use different kind of projection and different places of the light source, so the entire, there's several different kind of projection, and it all represent the same places of the world or the different places of the world. So that's completely different. In the world, the most common use, we say the universe transformator. So that's a 6 degree, which means from the meridian, from its east 3 degree, west 3 degree, divided into one zone. So the entire Earth, there are 60 zones. And this is the most common used to represent the entire world. We say the UTN system. So each country has developed its own coordinate system. Like I mentioned about in Taiwan, we use the transformator 2 degree. But the way to do that and the reason to do that is to represent the X and Y, the exact coordination. So let me go into the session 3, the structure of the GIS data. As I mentioned about the real world and how you can use a different layer to represent the real world. Use either vector data or the raster data. So these are the vector data. Use the point as where is the street, the cross street, or where is the unique building. Or use a line to represent the stream. Or the switch system. Use a polygon, represent the land use. Or we can use the raster data. Still, the raster data depend on your grid size or cell size. Or we call each one is a pixel. So depend on your pixel size or your grid. So each grid represent one thing. It's exactly the same thing. And but it also, if you're detailed enough, then it looks like exactly the same as the vector one, or use the polygon one. So this is the vector represent. This is the raster represent. But it all represent the same thing. Depend on what kind of analysis you're going to do. But nowadays, we always merge together with vector and raster together. Like vector, we can analyze. We can use that to count about the area, about the length, and also the possible information. And we use the pixel as a raster one, like the satellite, the drone maps, or the aerial photos together, and then represent the entire world. So we can use this as a vector format, as a point, as a line, as an area. Use nominal data, ordinal data, interval ratio data. So that's all the very, very common maps you can see in the world. So that's how the GIS has been developed. Like the point, use the nominal data, ordinal data, interval ratio data, or line, or the polygon. So using this kind of information, we can very easily use the line, use the polygon to represent the left-hand side, the right-hand side, which means the topology. So the good things of the GIS is, if you're looking at the GIS, the map, you know exactly if this is a road, this is another road, this is one of the land parcel. You know exactly this land parcel is located at all these roads right-hand side. And I know this if I look at entire attribute data, use the 0 and 1, I know the direction. So I know it's not joined together with the road itself. So I know the road and the land parcel is isolated. It's not joined together. The reason I know this because from the data structure. And also another kind of data structure is a digital terrain model. So we can still count as a vector grid, because in the real world, if we try to describe the service of the model is always, we can use a triangle one. Each triangle has one of the slope, degree, and the aspect, and also the area. And you can see if we go from the digital terrain model, the DTN, which means each point, we know the X and Y and the Z value, the elevation value. Then we can use this to represent as a team. Use a team, then we can create a three-dimensional model of the entire surface. So this is how the GIS being worked out. So what I mean by raster information? For example, we're looking at a spot image. This spot image, if we try to enlarge this site, it looks like this. So each grid size is 12.5 times 12.5. So in 12.5 times 12.5, there are three information: the green, the red, the near infrared. So there are 3 bands information, or even 4 bands information, including in each pixel. And that's how we can identify, like, this might be the water body, or it might be a shallow water, or it might be a bare land, depend on where it is. And if we're looking at the satellite images, the aerial photos, images, there are lots of information can be available nowadays. Use the pixel ones, or if we can use different kind of color to represent where are those kind of rice from, and where are the other kind of different vegetation things, and where are the roads, where are the kind of land use or land cover. So let me go to the section 4 about the remote sensing. What is remote sensing? Because you can remotely, you can measure of the object characteristic without the real contact. So you can use either camera, use a lot of like radio, or lots of things. Even can make photos. So telescope. And all those kind of things, we say it's a remote sensing devices. And nowadays, there's so many remote sensing devices nowadays. And also, most of those kind of remote sensing devices try to receive some of the signal either by active or passive. And we say active means the device can automatically send out some of the signal out. Or the passive one, as the device receive the other source, for example, the sun. The sun, or the spectrum reaction is directly in the about the Earth's surface, or the spectrum radiation is directly by the sun. So either the sun's has this kind of passive source, and also if we're looking at the spectrum wavelength, then we'll be able to see the visible light as human eyes can identify is from the green, the blue, up to the red one. But for the ultraviolet, for the X-ray or gamma, or for the higher length, about the near infrared or the microwave or some other low frequency things, is also something we'll not be able to see that. But as here, the frequency is much, much higher than here, because the energy is the same. Energy is the same thing. So if we have shorter wave and the speed of the light or the spectrum is the same. So which means it has to have very high frequency. So that's why we say the ultraviolet or the X-ray or the gamma is harmful for most of the human body because it has much higher frequency, much higher frequency. And all the other one, like the radio, the low frequency things, is harmless than the ultraviolet or X-ray or gamma. So the advantage of the remote sensing is we can very easily to obtain some of the information very easily, especially for the very large area, because we can use the satellite image or air photo or even the drones. Information can be very easily displayed in forms of graphic or non-graphic messages and reduce the manpower and risk operation. So nowadays, the aerial photos and satellite image are very common use, especially in Taiwan. It's very common use in Taiwan. We use that for the land management, use that for the disaster management, use that for the smart city, use that for the entire Taiwan island, for all the things. So let's talk about the remote sensing, some of the application. For example, these are the aerial photos. So from satellite, because follow the orbit and several 100 kilometers away. But for aircrafts, it's thousands meters away. So there are much good things to use the aircraft. So this is one of the aerial photo by the aircraft. Normally it can produce very high accurate and also very high resolution, much better than the satellite. But because the aircraft is still require the good weather condition, so these are some of very good aircraft photos. And in Taiwan, the government produce 1 to 5,000 the basic aerial photos for the entire island-wide. So the aerial photo is a government-produced database and is open access to all the people in Taiwan. So you'll be very easy to look at or to access some of the 1 to 5,000 aerial photo, except some of the we say there's a very high national defense area or military area, or some of the very privacy area. Otherwise, all the other places, it can be very easily to share from the website. And also the resolution, if looking at a 25 centimeter or 50 centimeter, or we're looking at the Taichung city, like this is one of the major commercialized city in the past 10 years. So you can see the development has been a very high developed. It's all the tall buildings now. So it's all being developed. And also, as you can see from this graph, this is the number of the satellite today. Like today, there are thousands of satellites can offer the kind of different sources of the remote sensing satellite information. Like for, we say, natural resources satellite can produce the images. And there's some other satellite produce different kind of information, like radar, like lots of information. So there is increasing sources of the Earth observation. This is why the several universities in Taiwan, we work out together, try to offer this kind of courses to all those students or who is interested in the space observation issues. And we're glad to share our experience. And we're glad to share all the kind of application, because hopefully it's the Earth is our motherland, and also we're looking at all this kind of increasing sources, satellite information around the world, and also now we're looking at the UAV because UAV now can provide lots of very good things. We say Internet of Things. It's IoT because it can equip with lots of different things. And if we're looking at the Internet of Things, everything can be connected with each other. And we can use the artificial intelligence, the AI, to represent not only to identify 0, 1, but it also can identify what it is, or what kind of thing it is doing, or if something happening. And we can produce a very good service platform. So the drone can offer this kind of information directly. So this is why the drone today can carry different kind of camera, different kind of sensors, and can create lots of things. Of course, we're not talking about military use drones. We talk about the kind of natural resources or the kind of commercialized or governmental used for the basic drones operating. So the most common drones can carry lots of different kinds of sensors. The camera is one of the basic equipment. But now there are lots of different kind of payload can be carried by different kind of drone. So like this kind of drone is a kind of, you can show, for example, like nowadays, if you're looking at several hundred drones or several thousand drones, can make a good show on the sky. So you can combine not only a flat map, but it's a three-dimensional map with different color. You can change the color. So there are lots of this kind of very, very commercialized drone. But basically, the camera, most common sensor, or video, or lots of the thermal camera, like can be produced to be carried by the drone. Use the thermal and identify about the thermal images. And it was only used by the military before, but nowadays, because it's become a very, very common device. So nowadays, lots of the drone can carry about this kind of thermal things. And it requires some license for export still, and it can receive lots of information, or even NDVI can easily identify the navigation, the vegetation index. We say the NDVI. So it can very easily identify if it's a vegetation or it's a non-vegetation for agriculture, for different kind of things. So there are lots of things can be carried by different drones. As this kind of visible light for the camera can be very easy operated by a drone to identify the entire places. And also the application with a visible light camera, and the drone can produce the ortho photo, just like the aero photo one. So with a fixed altitude and speed, it can create almost the same as a big aircraft before. So nowadays, the drone can also produce a very good ortho photo now. So because the ortho photo and can be produced, so nowadays the UAV can use for mapping now or surveying. Like before, we cannot use the UAV directly as a surveying, but now we can use UAV or even the RTK information. We can very easy to get the very correct coordinate. So it's very easy to get this kind of orthophoto joined together with the digital service model and use the image analysis. We can count about the area size. We can count about the volume of this kind of bare land. So we can get a landslide volume, we can get affected area, and we can have very, very precise position of the landslide. Like this is one of the landslide happening in Taiwan. So we can use the drone to identify lots of this kind of information. Or use the drone to carry this kind of NDVI camera. Then it's very easy to identify if there is vegetation or not, or what kind of crop it is, because the NDVI can provide different kind of spectral information. And even for the thermal, use the thermal, we can identify very easily about in the city where has the hot zone, where is the cold zone, and above all the building, which building site, which roof produce the most hot zone roof, or even for some of the construction. We use the UAV, carry this kind of thermal camera, and we can very easily identify if there are crack, if there are water leakage, which is not easy to be identified just by human eyes. But we can use the UAV carry those kind of thermal camera to identify all the changes or possible future risk of all the construction sites. So these can be identified very easily using the thermal camera because of the different refractors by the thermal camera. So it's very easy to be affected. And you're looking at, we are using the thermal camera carried by UAV and to detect the nearby, near the campus. This is the outside of my campus. So use the UAV. As you can see, we can very easily, even to track, this is a car, this is a motorcycle, that's a human being. And we can count about the number, and we can track the movement, everything. So we can very easily use this kind of information to identify a lot of things, or even in the night. This is not a thing can be easily done before, but now we can use the thermal image being carried by the UAV even in the night. We can very easily identify because the entire color, because it's a thermal refraction. So it's a temperature. All the temperatures are different. And use this kind of thing. We use the AI. Will be very easy to identify it's a car, it's a person, it's a motorcycle, it's a truck, or whatever it is, by the size, by the movement, or by lots of things. Of course, there's still some error about that, but we can use the machine learning, or we say the deep learning, to have this kind of identification to become smarter and smarter. So all these kind of things will be able to use by the thermal images with the AI. So in my university, we try to have self-developed UAV, or to buy the commercialized UAV and use all these kind of things to identify lots of things. And even we try to use the UAV to identify the coastal waste, because in Taiwan, there's also a very serious problem about the waste pollution in the coastal line. So using the UAV carry this kind of sensor, it's very easy to identify the hotspots and all the waste area. So use the kind of UAV or aerial photo. It's very easy to create the entire city, or to create one of the mountainside using the vector data, using the raster data, use the aircraft, use the drone. It's very easy to create all the information. And most important is all the information carry the attribute data, because we can overlay with all different kind of information. We can overlay with the land cover, we can overlay with the transportation information, overlay with lots of different information. Then we'll be able to realize what the real world is. For example, if you're looking at the left-hand side, this is the UAV photo. And as you can see, there are lots of cars on the roads. But we try to create a photo without cars. So we can use a very, very smart technique to eliminate the car, as you can see here. Unless this car is in a very, very slow movement. So if we can collect a series of the photos, then we'll be able to identify and we can eliminate the moving car. As you can see on the right-hand side, the same thing. As you see in the left-hand side, there are cars. As you see in the right-hand side, there's no cars. Because we can use a frequent photos, a sequence of photos, identify where are the moving cars and take it out to eliminate. So there are lots of things we'll be able to do. Okay, so I think I've been talking for probably more than 70 minutes. So let's take a 5 minutes short break. So you can drink water or just think about, and all the thing will be recorded. So you'll be able to review the entire courses in the future or anytime you like. So let's take a short break for 5 minutes. Thank you. Hi, everyone. I'm back. My name is Tien-Yin Chou. This is the second part of this afternoon session about introduction for the GIS. This is SOS course offered by the Taiwan Space Union. And I'm Tien-Yin Chou from Fengyang University. I'm the director of the GIS Research Center. I was talking about some of the basic information about the spatial information and how we can organize the spatial information using the GIS, and also how we can use the satellite image, the aircrafts, and also drones, and how we can use the vector data and raster data to represent the real world. And now I'm going to talk about session 5 and session 6. So session 5 is about the global navigation satellite system, because nowadays we need to identify where we are or where are the interest position of interest, where are the correct location. So that's how we call the global navigation satellite system. Before we just used the word the GPS, but GPS is launched by the US and it operates on the Earth and served the entire global resident for many, many years. But nowadays, not only the GPS, but also the GLONASS by the Russia before, and also the Galileo by the European Union, and Beidou by China. And also there are lots of different global navigation satellite system can offer the kind of location, either by Japan, by Israel, and so many different countries. So most area of the Earth, or the satellite will be able to produce a lot of this kind of information. And how the satellite can create the real location or the real coordination is based on the 2-dimensional and 3-dimensional positioning way. So if there are three satellites globally above entire Earth, and you can receive the signal from the satellite, and by different timing scale. When I say timing scale, is 1 of 100, 1 of 1,000 in seconds, because the speed of the light is the same. So all the spectrum or all information directly sent out by one satellite. And once you can receive that, and you know exactly the orbit information of that satellite, Then you can count the direct line. You have one line. Then you have second satellite, you have third satellite, and you have fourth satellite. Then you can operate it. So use 2 or 3 or 3 satellite, you'll be able to identify where your location is. And use the fourth one, you'll be able to tell the very, very exact one. So that's how the satellite, those kind of navigation satellite can provide a very, very detailed location information. And using this kind of technique, if all the satellite is under certain orbit and circle the Earth, then if the entire Earth can be operated by either side can have simultaneously at least 4 satellites, then we'll be able to identify the exact location. So that's 2, and that's 3, and that's 4. So if there are 4 satellites, we'll be able to identify a very exact location of the site. So the thing you need to know is how you can receive the signal from each satellite. And you have to identify the satellite orbit information. So using this kind of information, there are lots of uncountable GNSS in our daily life. Or the drivers and use the navigation for the road navigation, for the travel, or even use Facebook or Google Maps or search for the short distance or any location search function. There are lots of information. And before we use the GPS by the US, but now we use the GLONASS also by the Russia, and also Galileo by the European Union. And in your cell phone, it can also receive the Beidou from China. So in the world, there are lots of this kind of satellite can provide. And how we can use all this kind of information, how we can very, very wisely use all this kind of information. And I'm going to talk about some of the application things. One of the basic application things is, for example, nowadays we all suffer by the COVID-19, the pandemic. So globally, the COVID-19, there are so many different countries, so many different sites, so many different people are producing this kind of maps every day and try to find out how it's being spread out and try to find out what is the condition now. And because of COVID-19, lots of technique has been improved. The monitoring, the untouchable, and you can get the pass, and also the digital life. And all the world has been changed. The same thing, even the GIS has been changed. The GIS has been changed because the face-to-face encountered, or everything, you have to use some kind of different remote sensed information. So that's the remote sensing things has been increased. And also all this kind of maps, all this kind of information, and it can very easily to join together with different kind of model. For example, you're looking at different kind of hydraulic model to represent the possible floods condition, and you're looking at the underground pipeline or the sewage system, and you're looking at some of the water level being changed by the water gate, and if we can control the water gate automatically. So all this kind of information has been widely out in the world now. So there are so many usage of this very, very good information can be operated by either the GIS or the remote sensing. So there are lots of API has been developed by, in these 2 years, the globally suffered by the COVID-19. There are thousands, there are millions of the API has been developed. And all those kind of API and joined together with a very good Internet of Things and with a good AI, it can very easily identify a lot of things. It can easily identify a lot of things. Even like this one, there are maps, there are three-dimensional map, and there are aircraft, because all the aircraft above the air is sending out some of the information to public. And we can very easily receive those kind of information and join together with some of the satellite information. And we know exactly where the aircraft is now. Like the right-hand side, this is a three-dimensional one, and left-hand side is a flat two-dimensional one. But basically, we know exactly where is the aircraft and what kind of aircraft for the commercialized use it is. So these kind of things will be very easily representing in the graph. And also we know the routes of the aircraft. And all the information will be very easily to be identified. So this kind of information can be very easily used by different kind of technology. In this map, we use the GIS map as a vector form. We use the satellite image as a raster form. We use the signal out by the aircraft as a communication. Everything based on certain kind of standards. Then we can put everything together. You use either two-dimensional or three-dimensional to represent the entire things. So if you're looking at this one, you can also identify where the ship is. It's the same thing. The ship is going on the ocean side, and we know exactly where the ship is. And we can use the three-dimensional or two-dimensional issue to easily display. It's also being used a lot of different kind of information. And this one, we can very easily use this kind of service to identify the changes of the different year by satellite image. So use this kind of function, we can very easily to identify the lane cover change. So all this kind of application has been developed as a very good tools can be used for today. So it's not only by one basic information, but there are lots of information can join together. Even in Taiwan, the university is work together with the government with a high performance computing center in Taiwan. We try to use the data cube, which means we can very easily to extract a certain area and try to have this certain area to identify where are the betel nuts growth area. And we don't own any of the satellite image or the aerial photo, and we don't own the model to identify the betel nuts. So it's all been developed by different scholars, different university, different centers, and we can very easily share all this kind of information directly. We can very easily share about where are the betel nuts plantation. So these are some of the betel nut plantation has been identified directly using the AI. So this is one of the simple example of all the raster information, vector information joined together with model and all the interdiscipline knowledge about how we can identify the betel nut by different spectrum reflectors. And use this kind of information, we'll be able to do a lot of things. Like the things in the smart city. The thing in the smart city, we can use a lot of things in one of the city to develop about using the dashboard. We know what is the agricultural productivity now is going, and we know about the market price of each specific agricultural product So there's so many different kind of things, or even for some kind of construction site security. For all the working labor, they can very easily carry certain kind of device. So if they are going to some kind of, they're inside some kind of tunnel, then the device can reflect the exact location, or even if has been accidentally fall down. So this can avoid some of the accident happened and no one knows in outside. And also in the world, there's an organization called Open Geospatial Consortium. Fengyang University is one of the principal member of the Open Geo Consortium, and I'm serve as the chair of the OGC Asia Forum. And we're looking at several things. This is one of example, like how we can combine satellite image aerial photo for object detection using the OGC standard. The Open Geospatial Consortium has announced more than 50 standards. It's all international standard now, like the KML, KMZ, like the CT-GML, all those digitized information can be services is all Open Geospatial Consortium standards. So we're looking at the first, the GeoLayer 1, the Pleiades. That's a satellite, a very detailed satellite information. And we're looking at the radar sats. That's also the satellite, the radar satellite by Canada. And we're looking at the ISI. ISI has even more different kind of spectral reflectance and very, very detailed one. And also we're looking at the street video, the video camera. So all this kind of thing we'll be able to identify in one of the airport, and this is one of the object we can identify if this object is this one. So is this object is this one. So we join together with so many different kind of satellite image and real-time camera and real-time sensors and try to identify very exactly if this object represent this one, a small van, a white lorry, a medium-sized truck, or the same vehicle. So that's a question. So nowadays, we try to have all the remote sensed information to be as smart as human brain, or even smarter. So when the camera find out the kind of water has been splashed by the tire, then it can automatically identify the frost depth. Like this frost depth by the tire is 11 centimeter. So this is very easily can be identified about the frost depth by just one sensors. And it can has different sensors to double check the accuracy of these sensors. And it's all remotely sensors. So we can use lots of this kind of thing. We can use a cell phone to identify the road, identify the different people or motorcycle or lots of things. Like this is a street in Taichung City. So if you're looking at the Taichung City, the Fengyang night markets, and we can very easily use a cell phone to identify a lot of things. Identify is a car, is a motorcycle, and how is the roads from here to there. And you can navigate. And you can exactly tell me how to walk there. And who are those people I jump in. So everything can be very, very smartly. Like even nowadays in Taiwan, lots of the city offer the kind of trash truck position. And you can use your cell phone, or you can just open your TV in your home, and you'll be able to tell when the trash truck and what kind of trash truck, some of the different kind of trash trucks. Like some of the truck, it has some kind of waste resources dumping, or lots of different trucks will be able to identify. And you can know like when will the trucks is coming to my door, and you can carry your garbage out. So all this kind of information about the application I mentioned in today's course is basically offered by either from the International Open Geospatial Consortium or some of the commercialized, like the Digital Globe company. And also, this is the GIS Research Center in the Fengjiang University. And about the GIS Research Center in the Fengjiang University, you can easily query us on the website. So we have our philosophy about interoperability, about integration, and we use very good communication, and we always love to share. So sharing is also one of our basic logo in our philosophy. So the vision of us is to become the pioneer of the GIS application. And we have the manpower, more than 270 full-time employees. And each employee is equipped with different kind of license and different specialties. And most of them are very, very senior in the entire center. So lots of them have been working here more than 10 years, and some of them even more than 20 years. The major manager level is all working for more than 20 years. And we have lots of different kind of publication. And we offer lots of seminar papers or even journal articles with more than 30 good SCI or EI journal being published. And we have lots of different patents, and totally you have 52 patents regarding lots of our different technology. And we've been produced a lot of different kind of GIS books. Even one of the English one, or some of the software one, or some of the basic applications, basic theory one. And also we have lots of visiting and academic exchange. So we love to share about information international wide. And we have lots of this kind of special information education for kids, for high school, for undergrad, for master, for PhD. So as all the course material, you'll be able to see that there are lots of good information. So we're looking at the AIoT, which is artificial intelligence and Internet of Things together. We're looking at the three-dimensional GIS with the AR and VR. We're looking at the standard. We're looking at the data analysis. So we try to create a very smart city, smart AIoT, intelligent management, smart transportation, sustainable environment. So there are several companies inside the entire center. So hopefully we'll be able to produce a lot of things. And this is one of the courses we've already created on the MOOCs. It's called the Smart City Program. So the Smart City Program, we already offer these courses on the website, and it's completely taught in English. It's trying to represent what the smart city is. So we try to educate into 36 basic units. Each unit is only 12 minutes. So each unit is only 12 minutes courses, and there are 36 courses. And we invite several of our different lectures, talk about different issues regarding the smart city. You're welcome to look at this one in the MOOCs course from the website. And also in Fengjiang University, we offer the master program of the smart city. It's lots of courses can be taught in English, and also some is in the Mandarin Chinese courses. And we welcome different interdisciplinary students apply for the master program or apply for the PhD program. We have the PhD program about the geoinformatics. So it's an international program of the geoinformatics. And this kind of program, you'll be very easy to find out in the website. So we have the program offer the PhD program, we have the program offer the master program, or program offer the very common interdisciplinary MOOCs course. So this joined together with the Fengyang University, the GIS Research Center. So I'd like to thank you for your listening today and welcome you to join the GIS Research Center in the Fengyang University. And hopefully today's courses is useful to you. So I think this is about the entire course. I will open and also I will give the controlling back to the manager of the course, because after this one, we still have some quiz, so which is very easily answered. So the manager will give you the information how you can use the quiz and to reflect some of your opinion back. And also, I will be welcome you to have any question. So here are the QR code or the website. You can very easily write to the website or use the QR code to reflect any kind of information directly. We would love to share about all the information with you. So thank you. Once again, my name is Tien-Yin Chou. I'm from the director of the GIS Research Center in the Fengyang University. This is SOS courses offered by Taiwan Space Union. And thanks for a lot of different scholars from many different universities in Taiwan. We try to offer these 16 courses to you until this June. So every Monday afternoon, starting from 4 o'clock in Taiwan time, we expect you'll join us, and hopefully we'll be hearing from you very soon. So thank you. Okay, so I'll back to that manager to control. I think the managers can be control this one and can offer some of the very basic quiz to all of you. Okay, I think you can see on the screen. So thanks for listening to the course. And there are 2 very simple quiz in the end. The first one is, the following is not a GIS data format. You've heard I talk about a lot about different kind of format. And one of the things I didn't talk about in the complete course lecture. So that one is not the GIS data format, and which the following is not one of the global navigation satellite system. I mentioned a lot of things to you, use the satellite information. So one of the satellite is only for the resources, which means has only the image function, but not for the navigation function. So there are 2 satellites good for the navigation function, and one is for the image one. So which one is not for the navigation one? I think those 2 questions should be very easy, very simple to be answered. And once you can use your Google Docs information to answer your quiz. And once you fulfill the quiz, we'll be able to know you have registered and you'll be listen to this course. So very welcome you to listen to the course again from starting from this week
And also we'll keep going until the June. So there will be 16 courses, and welcome to join us together. Okay, so I think that's the end of today's afternoon course. Hope every one of you all have a very happy Valentine's Day. And I think for all the Asian people, this is very close to the dinner time. Hopefully you'll have a good dinner with your family or with the one you favor or the one you love. Thank you.